What is up, guys? Welcome back to another video. In today's video we have a huge one for you. We are upgrading and showing you guys how we built our DIY electric mini bike version 2.0. We have had so many requests to make an update video for this bike, so here it is, a full-fledged tutorial on how to build the upgraded version of the mini bike from last year. If you haven't already watched our previous video, make sure to go check it out before watching this one. It will make so much more sense with that one for context. We've spent the last few months upgrading many of the components inside of this mini bike to make it an absolute machine and more powerful than ever. The mini bike has been fully waterproofed, upgraded to a 16S3P P42A battery pack, a 200 amp motor controller, and an all-new mounting system that makes it more rugged than ever. Additionally, it's got that same massive 7 kilowatt motor that we had in the last video. So without further ado, let's get into how we built this thing. So just as a recap and a before picture, this is the mini bike that we made last year for YouTube. It utilized a 10S 5P battery from very low quality cells, as well as a standard inertian Fockbox single ESC that wasn't capable of handling that much current. It was an alright bike, and it was a great first try for us making this electric mini bike. It had a top speed of around 22 miles an hour and a range of around 10 miles. The hill climbing was also decent. It made it up pretty much any hill, but not that quickly, and the torque was very good. However, mini bike version 1.0 had several fatal flaws. First of all, the battery and ESC were severely underspec'd for what we wanted this bike to do and for the size of this motor. Additionally, the enclosure housing the ESC and the battery was just duct taped to the underside of the seat, which was very sketchy. We also failed to trim down the motor mount, which left two hanging pieces of metal that could cut one's leg at any moment given one wrong step. Version 1.0 was a very scrappy project. More than anything, it was just a proof of concept to see if we could actually make an electric mini bike that worked. Now that we know that we can, we took all of our concepts and everything that we learned and elevated this DIY electric mini bike project to the next level. Before we even got started on the build, the first thing to do was to tear down the existing mini bike. We basically stripped the entire mini bike of everything that we had put together other than the actual frame itself. We had three main goals when planning out what we wanted to do for mini bike version 2.0. The first was a battery upgrade. This was much needed to upgrade the top speed, the range, and also provide more power to the motor. The second was to devise a new mounting system for the battery to the mini bike. This involved picking out a new enclosure and figuring out how it would sit on the actual frame. Third and finally, we wanted better brakes for increased reliability and safety. With this in mind, we set off on making mini bike version 2.0. The first easy update was to use a reciprocating saw to cut down those two metal pieces that hung off the edge of the mini bike as a part of the motor mount. These never got cut off after the first video, so we were happy to finally make this change. We then went to Home Depot to get some 1/2 inch by 24 inch black steel Schedule 40 cut pipe. This is going to be used as the new bracket that will hold our battery in place. We then used a hydraulic pipe bender to bend this pipe into a 90-degree angle. Using both the mini bike frame and our new enclosure as reference points, we marked on the pipe where it needed to be cut so that the enclosure would fit perfectly into place for the new mounting system. We then used the reciprocating saw to cut down the 90-degree angle pipes to the proper length so that they could be welded to the frame and hold the battery case. The ends of the pipes were then grinded into semicircular shapes using an angle grinder so that there would be the most possible surface area between the pipe being welded and the existing mini bike frame so that the joint could be strong. The motor and motor mount were then removed from the mini bike frame as to avoid any damage during the welding process. The two new battery support pipes were then welded to the already existing mini bike frame. The idea behind this design is so that the battery can sit on top of something. This is one of the major flaws with the first mini bike, as we just taped it to the underside of the seat. Now there's actually something connected to the frame that will act as a way to hold the battery from the bottom up. Overall, I'm super pleased with how it looks, as it retains that exact same retro 60s look with the exact same steel piping. We then cut some flat metal that would be used as a brace to connect the two pieces and then hold the battery. This was also done using a reciprocating saw. We made two of these thin strips out of one long thin strip of metal and then welded them to the steel piping, not only to brace the two against one another, but also to act as a flat place for the battery to sit on top of. So here's how the welding turned out for those two flat strips. I think it's going to be a great spot for the battery to sit. We then measured how far we needed to put the bolts through them because we're going to be fastening the battery box to this. We cut out another piece of that flat metal, which will be going inside of the enclosure. We drilled a hole through both pieces of metal so that they would be lined up perfectly, and then installed this piece of metal inside of our battery box and drilled a hole all the way through both of them that was slightly larger. We then put the bolt through one of them and the nut inside of the enclosure and screwed it down all the way before repeating the exact same process on the other brace so that there would be 2 bolts holding our enclosure in between that newly welded piece of flat strip metal and the piece of flat strip metal already inside of the enclosure. Essentially, we just made 2 holes for 2 bolts and 2 nuts to hold the enclosure to the mini bike frame. With the enclosure mounted to the mini bike, we tacked those nuts into that piece of flat metal inside of the enclosure. This will hold the nuts in place when we screw the bolts through the bottom of the enclosure once the battery box is actually closed from the top. Right now we still have access to them, but once it's closed and sealed up, the only way to screw it in is if the nut is locked into place. After having finished this process, we did take the bolts out so that we could actually work on the internals of the electronics and then secure it on later. I love this new design for mounting our new battery to the mini bike, as it's so much better than our old duct tape version. This is going to retain that exact same steel piping look throughout the entire bike, and it's going to look like the bike actually came like this without having to be welded on once it's painted up. Welding metal pipe is also going to be a lot stronger than just duct taping our battery to the bottom of the bike and make this design more safe. So just to clarify, this flat piece of metal with the 2 nuts tacked to it will go inside of our enclosure. It will be used so that the bolts that thread through the bottom of the frame and into the enclosure will secure that battery box to the bike. It's got a lot of area, which is really going to reduce the amount of pressure applied to the plastic enclosure. So after finishing the welding, we just cleaned it up a little bit by using a grinder to just shave down all of the welding joints to make them more smooth and easier to paint over and look clean. With the welding done, we took off the rear wheel assembly to allow for spray painting. Considering that we were always going to have to take off the rear wheel assembly for spray painting, I definitely should have done this before welding just in case it could have damaged the tire, so that is definitely a well-learned lesson for the future. The newly welded piece was definitely in need of a paint job, as it did look quite dinged up after welding and bending those pipes. We first primed the bike using a white primer, that way the blue paint that we applied on later would stick better. We used the exact same color that we've previously used on the mini bike to retain that same blue look that we have on the old mini bike. This is what the mini bike looked like after having been painted, and that newly added piece of metal piping looks like it was actually part of the frame from the beginning, so I'm in awe of how well it turned out. I've continuously mentioned and shown this box previously in this video, but just to go into more detail, this is an ABS plastic dustproof and waterproof box rated for up to IP65. It's 11.4 by 7.5 by 5.5 inches, and I got it off of Amazon for right around $40. It's going to house all of the electronics for the mini bike build. It's got 2 very secure but easy to operate latches for easy access into the internals of the electronics when it's fully complete. The 2 holes that I've already drilled in the bottom of this box are already there in this shot, and as you can see, the flat plate will rest inside of the box, the bolts will go through the bottom of the frame, and then lock into there, securing the box to the newly welded on piece of the mini bike frame. Although the nuts are already tacked onto that flat piece of metal, I figured that I'd also add some JB Weld epoxy on there for extra security. They're unlikely to come off, but just in case, I layered the entire nut with some epoxy, that way it would be more securely held into place. For added protection against vibration and from those sharp edges on the bottom now in that metal plate, I cut out a few pieces of foam to put on the bottom of the battery box. There's also a couple more that will be going on the sides that will also protect the electronics from any other thing that could ding them. Once we figured out the fitment, we spray painted the box black. With both coats of paint now on the bike and the enclosure, we retested the fitment to see if it would work. Obviously the lid is off in this picture, but just to ensure that everything still lines up, we double checked. And this is what the box will sit like on the frame. Once again, it will be bolted through the bottom so that it's secured into place. Now to move into the electronics, which is where I think this build starts to get very interesting and highly upgraded. The battery we are using is a 16S3P P42A Moly cell battery custom made for us by none other than our favorite battery pack builder, Eastgate Alex. This battery has a 60% higher voltage than our first mini bike build and nearly double the capacity at around 700 watt hours, which will greatly increase our top speed and our range. There is an XT90 anti-spark for discharge, which will plug into the ESC, and then an XT30 which will plug into the charge port. There's also a fuse between the battery pack and the charge port for added protection. As you can see, the XT30s plug in here. There's a female on the fuse, a male on the battery, and then a female on the other end of the fuse, which will plug into the male on the charge port. This way we can mount the charge port inside of the enclosure without having to unsolder and resolder anything, just unplugging the cables. This battery is absolutely massive and a must-have upgrade for the mini bike. It's going to really allow that motor to be fully pushed to its limits now. As you can see, it's also orientated in more of a brick formation, and the BMS is bypassed for discharge. The next part we have is the ESC. We are going to use the Maker X Go FOC HI100 from Maker X. This ESC can handle up to 100 amps continuous and 200 amps peak current. Additionally, it can handle up to 75 volts, meaning that it can run batteries from 4S to 16S. The bullet connectors are 5mm bullet connectors for motor connection, which is what we have on our motor, and the battery connection is an XT90, which is perfect for our battery. All of the ports on the Maker X, however, do use a GH 1.25 JST connector, which is, in my opinion, a terrible connector because no other product uses it. I really don't like them because that means we're going to have to solder up custom connectors for everything on the mini bike. The casing around the entire ESC makes it feel like a very premium product and acts as a heatsink for this, which is going to really allow for peak performance. We'll leave a link in the top right corner here for our review video on this ESC to learn more about it. We'll also leave a link in the description below for the Maker X. As for the motor, we are still using the same 8100 130 kV motor from FlipSky with the Home Depot L brackets from last time. Obviously they are shaved down now, as you saw at the beginning of the video. We also have that 15-tooth sprocket mounted to the motor. FlipSky rates this motor as being able to do up to 14S, but I've seen other websites that go up to 18S, which is why we decided 16S was okay. They also rate the max motor current at 148 amps, which is absolutely insane. The max power that they rate this motor for is up to 7,000 watts. We will leave a link in the description below for this motor so that you guys can see all of these specifications for yourselves. We are also upgrading from an anti-spark key to an anti-spark switch. This one is from FlipSky. It's rated for up to 26S and is actually a water-cooled power switch, although we are not going to be using that function. It's rated for up to 200 amps. It's also got some really cool features such as a roll to start and an auto turn off that automatically turns it off after 20 minutes with no operation. It's also important to note that this power switch is very big. It's going to take up a lot of room inside of the enclosure. It's much bigger than any other Eastgate power switch that I've used in the past, and it should be, as it's going to be handling a much higher voltage as well as a lot more current. Another much needed upgrade is the addition of an actual electronic brake lever. Before we just had a reverse throttle for the brake, now we have an actual brake for the brake. It's got 3 wires that come out of it just like a standard throttle, but it's going to have the function of brake. As you can see right here, it's going to feel and look like an actual mechanical brake, but it's actually going to be an electrical brake. Not only is this easier to operate, but it's going to eliminate a lot of the confusion of having a throttle on the right side and the left side, one of which is for accelerating and one of which is for braking. We are going to use the exact same throttle as last time. It worked quite well. Same thing, it's a positive, negative, and then a signal wire, 3 pins. We soldered the corresponding XT90s onto the power switch so that the outside would have the one going into the ESC and the inside could take the battery. Next, we began the process of soldering up the Hall sensor wires and all of the connections for UART between the throttles and the ESC. These are the GH 1.25 JST connectors that came included with the Maker X. We used these as the basis for our connections. For the Hall sensor wire, we took a standard Hall sensor cable and then clipped it in half, soldering this to the GH 1.25 included. This process was super annoying because the wires are super thin, but it did end up working. The result was a sensor wire adapter that connected our 8100 motor to the GH 1.25 pitch JST on the Maker X. We also soldered up an adapter for the 2 throttles. For this, we used the UART cable that goes into the COM port on the Maker X, and then we used 3-pin JSTs. One of these will go into the throttle and one of these will go into the brake, and it's going to make it really easy to distinguish which cable goes to what and unplug the throttle and brake if needed. So as you can see right here, this end will plug into the Maker X, the GH 1.25 pitch JST, and then those 3-pin JSTs on the other end will plug into the 3-pin JST on the throttle and the 3-pin JST on the brake. To get the brake up and running, I actually had to solder up an extender wire to the existing wire on the brake, just using a cable with 3 different wires that I got from a previous throttle. We soldered that 3-pin JST on the end. This way it would plug into our new adapter. All of these 3 pins were manually soldered on, and they are JST 2.0 PH 3-pin connectors that we got from Amazon. At this point, the electronics were ready for assembly, starting with the core components, which are the battery, power switch, and ESC. So this is a very simple process. The battery plugs into the inside on the power switch, and then the power switch outside plugs into the Maker X. If it's done properly, you should be able to touch the power switch and the Maker X should turn on and the power switch should glow blue. Next up, we have the connection between the ESC and the two throttles. So we're going to use that UART adapter we made, plug it into the UART port, and then we'll have those two 3-pins available. It's important which one goes into which, as in the brake must go into a specific one and the throttle must go into a specific one of these 3 pins. So quickly, here's the schematic for how to hook up the brake and the throttle up to the ESC. So there are 3 wires coming out of the brake, the positive, the negative, and the signal wire, which are connected to our 3-pin JST. Then we have the throttle, which also has 3 wires, the positive, the negative, and the signal, also into the same JST. So there are 4 pins that we are going to use on the UART port on the VESC. The 3.3 volts, which will connect to both of the positives on the throttle and the brake, so those are wired in parallel to one another. And then we have the ground, which is going to connect to the negative on the brake and the throttle. These are also wired in parallel to one another. And then we have ADC1 and ADC2. ADC1 will go into the throttle. It's important it goes into the throttle and not the brake. And then ADC2 will go into the brake. So that is the wiring to hook up any sort of throttle and brake based on ADC control up to anything that's going to use the VESC tool. This diagram is particularly important when making that adapter that's going to go between the throttles and the VESC. At this point, using the schematic for reference, we connected up the throttle and the brake to the connector that we made that goes into the Maker X. It's hard to see and follow using the footage from the camera, so if you're planning on understanding how this works better, I highly recommend just looking at the schematic. Connection between the motor and the ESC is quite simple. All we did was connect the 5mm bullet connectors from the ESC to the motor in any order, and then connect the sensor wire from our motor into the Maker X using that adapter that we made earlier. At this point, it was time to program up the mini bike using the VESC tool. We won't show you guys fully how we did this as it would take too much time out of the video, but we will show you guys our settings. After updating the firmware and connecting up the ESC, the first thing that we did was to use the motor wizard to do the motor detection. We selected the large outrunner motor for the motor detection proper motor size. We then toggled under the general motor settings to set all of those proper limits. The max motor current max is 130 amps and the max motor current brake is negative 130 amps. The battery current max is 80 amps and the max regen is negative 12 amps. All of the other tabs in here are fine, except for the advanced tab. We set the duty cycle current limit start to 85% to prevent any cutouts. Next, we went to the ADC settings, and in the general tab, the app to use is ADC and UART. We then toggled over to the ADC tab, and under general, the control type is current no reverse brake ADC2, which will give you a throttle and a brake with 2 different ADC inputs. Under mapping, we set the voltages to the proper mins and max using both of the throttles. We then went to the throttle curve, and you can really play around with what you want here. Right now we have ours set to exponential and 10% on both the throttle expo and throttle expo brake. It's really nice that you can play around with your desired throttle curve to get as hard of an acceleration or as low of an acceleration as you want. It's definitely one of the advantages of having a VESC-based controller. So those are our settings that we are using on the mini bike at the moment. If you guys have any questions, leave them down in the comment section below, and we can make another tutorial if you guys need further information. With the electronics finished up, it was time to assemble everything together and put the electronics inside of the waterproof box. To route all of the wires from the outside into the waterproof box, we are using these electric conduit fittings which we got from Home Depot. The goal is for these to create a water and dust tight seal between the enclosure and the outside world to prevent any potential damage to the electronics. The large fitting will pass through the motor wires and the small one will have the brake and throttle. So we took out our box and mocked up where we wanted the conduit fittings to go, and then marked the location using a screwdriver. We then used a drill to drill holes in the side for the conduit fittings to pass through. With the holes drilled, we installed the conduit fittings on the enclosure, first by putting it in, then using the rubber retaining seal, and then the locking retaining ring on the inside over the thread. We repeated this exact same process for both conduit fittings so that they were both installed firmly and tightly inside of the enclosure. The next step was to route the power switch and the charge port through the waterproof box, so we mocked up where those would go once the battery was inside of the enclosure. We then drilled holes for both the power switch and the charge port. We then threaded the charge port through the hole on the left side of the enclosure and used the retaining nut on the inside to secure the charge port to the box. We then repeated this exact same process for the power switch, utilizing the hole that we made on the right side of the box. With the electronics done and the bike frame repainted, it was time to reinstall the rear tire on the mini bike. We used the exact same assembly as in the last video, the medium spacer on the outside, then the drum brake, then the small spacer, and then the actual wheel assembly with the sprocket and chain already on it. On the other side, you just have to squeeze in the largest spacer, which is a little bit finicky. We then tightened the nut holding the wheel onto the mini bike. We then mounted the motor mount and the motor to the bottom of the mini bike, first looping the chain around the sprocket so that it would be properly aligned. We then used the 3 M8 cap head screws to mount the motor mount to the bottom of the mini bike. The bolts go through the bottom of the bike and the nuts go on the top of the mount. We also used washers to spread out the force and provide less of a strain on the metal that holds the motor mount. We also made sure to properly tension the chain. At this point, we began the final assembly of the waterproof box by securing down that retaining nut plate to the bottom of the waterproof box. To do this, we inserted the bolts through the bottom of the box and then aligned up that plate and bolted it in. They were then immediately removed after the double-sided tape secured that plate in place because we will need them out to actually mount them to the mini bike. We also added in all of the foam that will protect the battery and all of the electronics from any sort of vibrations during riding. We put 2 pieces of thick foam on the bottom so that the battery does not get damaged on that retaining nut plate. We then put the battery in and put 3 other pieces of foam on 3 of the sides of the battery that will be touching the wall. We added hot glue to the retaining nut on both the charge port and the power switch just to secure them in place more firmly and act as a waterproof seal. Using a 3M double-sided sticky adhesive, we then secured the Maker X ESC to the top of the waterproof enclosure. We also connected up the power switch, then inserting it into the enclosure and connecting it to both the battery and the Maker X. At this point, it was time to finish up the conduit fittings by threading all of the wires through the outside into the inside of the enclosure. We first threaded through the UART cables, which connect the throttle and the brake to the ESC. These will go through the smaller conduit fittings, as the wires here are much smaller and delicate. We then repeated this process for the motor cables. We inserted the sensor wire as well as 3 motor cable extender wires. We had to use extender wires as the wires that we had on the ESC and motor were not long enough. We then finished up connecting all of the proper wires as diagrammed earlier in the video in a huge jumble of a mess inside of the enclosure. It was a super tight fit, but it did end up closing and working. From the outside, the box looks super neat and the conduit fittings do a great job of threading the wires from the outside to the inside. It's also going to be waterproof thanks to those. The next thing that we did was to install the electronic brake on the handlebars. It's a pipe shape and so is the brake, so it slides on very nicely. We also added a grip that was included with the mini bike for added comfort when riding. And next, we mounted the seat to the mini bike frame. We had to do it before we did the enclosure, as once the enclosure's on, we will have no access to the bolts that hold the seat on. We then slid the waterproof box enclosure onto the mini bike frame. We also added a rubber washer between the plastic box and the metal frame as a dampener. We then used the 2 M8 bolts to mount the battery box firmly to the mini bike. If you recall, these thread into those nuts that are in the plate already inside of the enclosure. With the box mounted, we connected the motor phase wires to the motor wire extenders. We marked which ones were which as we have already programmed it and can't go back inside, and they need to be in the exact same order. We were then able to install the throttle onto the handlebars of the mini bike. It's also the exact same tube shape as the handlebar, so it just needs a little bit of pressure to fit on the bar. To secure it down firmly, there's a grub screw on the side which just screws into the side of the pipe on the mini bike. We then zip tied all of the cables to the frame of the mini bike so that they don't just flap around when we ride, and they're neatly organized and unable to snag on anything. We also added 2 Shredlights SL1000s to the front of the bike using their bar mounts and 2 SLR1s to the rear also using the same bike mounts. It helps us ride at night and be seen. At this point, the bike was done for the first time, but we realized pretty quickly that having to take off that entire waterproof box just to reprogram the ESC and make any tweaks was a massive pain. What we did was we bought this micro USB extender cable which we're going to thread through the outside of the enclosure. This micro USB adapter will allow us to easily make tweaks to the mini bike without ever having to open up that massive enclosure. Just plug in the bike from the outside and make any tweaks we want to. We cut another hole right below the 2 electric conduit fittings for this micro USB adapter to thread through. It was a very similar process to installing both of the two electric conduit fittings, the charge port, and the power switch. The adapter stays plugged into the Maker X at all times so that we always have access to programming the ESC from the outside of the bike. The port looks super clean from the outside and even has a waterproof cap to retain the waterproofness of the enclosure. Having this feature has been an absolute must-have to be able to tweak the bike exactly how we want it. Just unscrew the cap and bam, we can unlock the possibility to customize the bike and ride feel exactly how we want. And just like that, the mini bike was done. This is what the finished project looked like. And there you guys have it. That is our version 2.0 mini bike build. This mini bike is so much better than the version 1.0 in every single aspect. The top speed is around 34.8 miles per hour. We've gotten up to 27 miles of range on a single charge, and this thing has absolutely crazy acceleration, torque, and hill climbing ability. I'm also just really happy with the way that the entire bike turned out both aesthetically and structurally. The waterproof box is a fantastic addition that really protects all of our electronics from the elements. Additionally, those two metal pipes that got welded to the frame fit in seamlessly to the aesthetic of the bike and provide excellent support for the electronics battery casing. Another feature that I absolutely love about this mini bike is the fact that it uses a VESC-based ESC, which means it has ultimate customizability. We can even access the VESC from the outside of the enclosure, meaning that all we have to do is plug in our computer to the bike and we can effectively change the throttle curve and the whole feeling of the bike in minutes. Overall, the electric mini bike is an absolute thrill-seeking machine. It is so much fun to ride, and anyone that's ever requested to try this bike has absolutely adored every second on it. The 34.8 mile an hour top speed is absolutely wicked, and the 27 mile range is absolutely crazy and farther than I ever would have expected going on this bike. The power is absolutely out of this world and more than anyone would ever need on a mini bike like this. We will be releasing a video in the near future where we showcase how we tested the bike to get these specs, so make sure you're subscribed to get that video update. For those of you guys wondering what the mini bike sounds like, here's a clip with raw audio. Despite this bike being nearly perfect in every aspect to us, there are still a couple things that we would like to change. The first is the braking system. We still only have an electronic brake on this bike. We did not install the drum brake on this version of the bike, which is a massive flaw because any sort of electronic failure would result in a complete loss of brakes. So that was definitely a really stupid idea, but so far it's panned out okay for us. A couple of other nice tweaks would be the addition of a percentage indicator so that we know how much battery we have, and a speedometer so we know how fast we are going. If you guys have any other comments or suggestions, leave them in the comment section below. We would love to hear your thoughts on this mini bike. So there you guys have it. That's it for the build video on mini bike version 2.0. If you guys have made it this far and enjoyed the video, please make sure to leave us a like and subscribe to this channel for lots of other DIY electric mini bike, electric skateboard, and electric vehicle content. We've got a ton of super exciting videos with the mini bike, electric skateboards, electric scooters, and DIY one wheels coming out later this summer, so please make sure you're subscribed if you want to see any more of that. So thank you guys so much for watching, and we will see you guys in the next video.